Hmm. Oh, hello, all 8 of you. Sorry if you were waiting for me to say something. Um. Alright. Decided to start early. Just because I cannot wait to do math. It's the best thing ever. Especially math homework. Okay, yeah. Yeah, I guess I can say some stuff. So I'm either going to do today my real analysis homework or my number theory homework. What do you mean new math? Let's see. Engage with your audience. I never do that. Start a poll. Okay. So I'm either going to do today my chat window. That ain't happening. How do you start a poll? I swear like YouTube's UI and Discord's UI is worse than using like just terminal utilities. It's more confusing. Okay. You'll have something to interact with in a second, don't worry. Yes, okay. It's number theory or real analysis. No, I'm not putting on. I have to do math homework. This is serious. I'm in danger of getting a bad grade in some of these classes. Please do not vote for real analysis. I would really rather not do that. God damn it. Oh no. Real analysis is so hard. And I don't really have the intuition yet for like the real analysis stuff. Like I don't know. It's week 2 in this class and like we haven't had a homework assignment yet, so I'm gonna get absolutely slaughtered. It'll be like very embarrassing. So ideally not real analysis. Also today I wanted to look at a couple of things. There's something that came out recently actually. Let me just look it up. Someone posted it in my Discord. Like OpenAI today, actually someone in chat told me this. OpenAI today came up with like a LaTeX editor, AI powered LaTeX editor, and it would be interesting to try that. I was typing all my homework in Typed, but I think Typed might be better for math papers than math homework, to be honest now. Yeah, and this is like my first time exposed to real. Oh, Prism, yes, thank you. Yeah, okay, I'm gonna start doing the homework. Actually, maybe I can actually get away with not doing real analysis. It's dropping. Oh, it's dropping more. Yeah, I don't know, but honestly, like LLMs for generating LaTeX, it's a really good use case. Especially because you can like do all your math homework on paper and then OCR into LaTeX. And there's like an argument that you're not learning LaTeX or you're not learning types, but I feel like I already put too much time into learning like typesetting, and it's like not a huge it's not like a I don't know, it's not that valuable of a skill, honestly. What do you need to sacrifice to get into this silly Discord community? Like ideally a goat or a sheep. We'd appreciate that. If you are on the wait list, it's just we're slowly building this community so it doesn't like collapse. You know how Discord servers tend to like get no interaction. Okay. I'm going to start doing this math homework. It looks like real analysis is still in the lead. Fuck. Okay. This is the analysis homework. And honestly, I don't see a lot of analysis in this. This is like pretty simple, discrete math, I guess. It's probably gonna rely on some properties of the reals, and maybe like there's an induction. I think does anyone do math here? Because that's really gonna be crucial to me succeeding on this homework. If not, I'll just end stream. Pentagram pattern. Okay. All right, I'm just going to start doing this problem. Hopefully someone comes along and can help me out with this. I think I'm trying to do math on stream or just do math with people. Doing like your homework with people, especially for pure math and computer science, is so much better. It's like standard deviations better than doing it on your own. And if you're just like sitting in math class alone, which I see so many people doing these days, it seems like people are less social than they used to be. And our professor was like, you guys, I'm gonna be honest, like you are not talking enough and you're all gonna like do very badly. So yeah, if you're ever in a math class, especially pure math, like talking to the other students and making friends in there and solving proofs with people is crucial, because you can learn about like how to think about problems from talking to other people. They don't even have to be better than you. It doesn't have to be like a mentor, but having someone to work with it makes you so much better. And same thing with pair programming. Even if it's someone at a similar ability level to you, it's just to have like access to someone else's thought process is amazing, because you'll realize like certain ways to think. Like people will think in ways that you're like, wow, I never even thought to think that way. It's helpful at like a meta level. So ideally there's some people who here know a little bit of math in chat. If not, I'll try to drum someone who can understand some of this from my Discord, but if not, maybe I'll just find someone in my class too, because ultimately I just want to get this homework done. All right, so let's get rid of this. I don't think you guys really need to see that. All right, so we're proving prove that no rational number whose square is 12. Prove that there is no rational number whose square is 12. Okay. There is no rational number whose square is 12. This is definitely like a proof by contradiction problem. And I guess whose square is 12. So I guess that's my intuition. And maybe I shouldn't start writing the proof yet, but is that clear enough? Should I zoom in? Yeah. Okay. So, and there's that famous proof that's for 2, but it's been a while since I've done this, to be honest. Oh shit. Hopefully my camera's propped up on 2 ski poles right now and they're kind of slipping. Okay. All right. So I guess assume towards that there is a rational number whose square is 12, which means that there's some kind of rational number whose square equals 12. All right. Now, how is this contradiction going to come in? I guess we say that this AB is in like its most reduced form, and then we try to find out that actually it wasn't in its most reduced form. I guess that's probably the strategy. Yeah. Yeah. Thanks. I also like this. So I guess, so this might be wrong, but and A, B is lowest. Or it doesn't, there are no other divisors. That's the, what's the word for that? Oh my God, I'm blanking. It's in reduced form, I guess. Okay, and then like that would mean a squared over b squared equals 12, which would mean a squared equals 12b squared. But what we want to show is that there is no rational number. So how is this going to result in a logical impossibility? That AB is in the lowest form. Oh, man. Well, God. It's a good thing I'm doing this on stream. This is like disastrous. We have to show Can someone, is that 10 and 12? What are you saying? It's proved that there is no rational number whose square is 12. Look at the square of a number, okay? All right, a square of a number. A square of a number is just the number times itself. I mean, I guess sure, prove that there's no rational number whose square is 12. I mean, what you could... No, that wouldn't work. A and B are integers, right. A and B are integers, and 12b squared has to be a rational number. Why does 12b squared have to be a rational number? Man, what a... Right, A and B are integers, so A equals something has to be an integer as well. Would be to use the fact every natural number can be represented as a product of a set of prime numbers in a unique way. Can you elaborate on that? I'm not exactly sure how that would help. Yes. 12b squared has to be rational because of what you assumed. Yes, that's true. Okay. But what's the contradiction here? And A over B is in lowest terms. A squared has to be divisible by 4 or 3. Ah, does it? Does it? That's an interesting observation. It has to be divisible by 4 or 3. Right. That's interesting. Okay. And so 3 divides a squared, or 4 divides a squared. And then since we know that 3 divides a squared, we have we get a contradiction, I guess, because we said A over B is in its lowest form, its most reduced form, but well, I'm still not sure that that's saying that square root 3 is irrational, insufficient. Okay, what if we simplify the equation to a squared equals 3 times 2b squared, and then take some part as k, and then try using prime factors for it? I'm not exactly sure what you mean by try using prime factors for it. Oh. Wouldn't it be a bit easier to take 2 squared out and then prove that the square root of 3 would be irrational? I think that's an interesting angle. So you're saying that basically this move down here, a squared equals 3 times 2b squared. Rearrange it like that. Okay, each natural number a and b can be represented as a unique product of primes. Yes, that's true. And so that each natural number, so a over b squared, have an even number of primes as its representation. Well, is a over b squared necessarily natural in its representation? 3 occurs an odd number of times. We can write prime factorization for left and right and look at power of 3. On left it's even, on right it's odd. Yeah, zoom in on the paper ever so slightly. Yeah, I can do that. You gotta drag the corners here. OBS is janky software. Alright, apologies if I'm mentally slow here. I'm just really trying to understand this to the best of my ability. Okay. 12b divided by a equals a over b would suggest that 12b equals a and b equals a, which is impossible. A over b times a over b equals 12? Yes. A over B times A over B equals 12. Sure. So then, assume for contradiction that there exists a rational number r such that r squared equals 12. Write r equals ab, where a and b are integers. I think this is interesting. Sorry, your name is very hard to pronounce. It ends with an AI. Faith Karan. Okay, that wasn't that bad, actually. I take that back. You're saying if we have, so I'm going to start a little over here, actually. So if we have a over b squared equals 12, we have a over b times a over b equals 12, or alternatively a over b equals 12b over a. And do you know what the outcome you're looking for with this contradiction? If you do, it would help a lot in knowing what you need to show. I mean, what I vaguely remember is like you want to say this is the most reduced possible, and then you're like, no, never mind. Here's another factor we can pull out of it. Therefore, that's a contradiction. If a over 2 squared times 1/3 equals b squared, show that a rational square divided by 3 is never a perfect square. Man, like I'm stuck in symbol paralysis here, dude. That also means a equals 12b. No, I'm not currently in contact with my father, Luke Smith. Okay, so a over b equaling 12b over a. Is that problematic? It has to be. But I'm just so smooth-brained at the moment. Why is that? What's the trick here? Does someone... So you've assumed that a and b are in the set of integers. Yes. Yes. Okay, where b is greater than 0 and the GCD of both of them equals 1. Like what you said, you want to show that the GCD is not equal to 1. It's not in the most reduced form. Yes. Okay. So they're both integers and the GCD is equal to 1. Okay. So we're breaking that they're both integers and GCD is equal to 1. And I don't know, honestly, that we're allowed to use the fact that root 3 is irrational. Maybe we are, I guess. Yeah. Yeah, I'm not especially like. Okay, I see that argument now. That is smart. Okay, that is all right. I'm slightly smarter than I was previously. That's nice. Um, I get what you're going for with this whole Route 12 thing. However, yeah, I'm not sure that's allowed. Maybe it is, but um, let's see. Um, yes. So when you have a squared equals 12b squared, you can say a squared equals 2 squared times 3b squared. It may be beneficial to write in terms of another variable. Say a equals 2k, where k is some integer. Okay. Okay. I think you mean... Wait, can someone explain to me what the deal is with breaking 12 down into two primes, which I guess is 2, 2, and 3. That's 3 primes. Why would you do that? Because we know primes can't be divided. A squared equals 12b squared. See that 3 divides a squared. So from... Yeah, so yes, we do see 3 divides. 3 divides a squared. And we also why is 3 dividing a squared a contradiction? Break down into primes tells you 2 and 3 divide a. Okay, so both 2 and 3 divide a. Path you're trying to go down is that a and b share a factor greater than 1. Oh, yes. It's really Ren is helping me out the most here. You're cooking, dude. Yes. So they share a factor greater than 1. Okay. How can we show that they share a factor? Three divides a, and to show that they share a factor, right? We basically want to show that like some k divides a and k divides b. And we know that 3, well, I'm confused here because of the squares, to be honest. That's throwing me off. Like we want to show the GCD AB, but we've got the squares. Yeah, I see the method with square root 3, and that is probably a lot easier. I just don't want to use the fact that square root 3 is... yeah, the square root of 3 is irrational. Just for the exercise of it. I think you're getting a bit tripped up. What you're getting a bit tripped up on is that you have a factor of a squared. If you can get a factor of a from that, you can then find some factors for b. That is where more variables could help. The bit you're getting tripped up on is that you have a factor of a squared. If you can get a factor of a from that, then find some factors for b. So factor of a squared. How would you get a factor of a from that? That's where you could use, where more variables could help. And you say it may be beneficial to write in terms of another variable, say a equals 2k. And so why can you say a equals 2k? Is it because man, wait, if 3 divides a squared, then 3 divides a. Okay. Yeah, I guess I get confused by that notation so much, which is a real problem. But so if 3 divides a squared, that's the same thing as writing like 3n equals a squared. And so basically you could say, you could square, then 3 squared divides if a prime divides xy, then the prime divides either x or y. You have a squared, 12b squared. So from that you get, sure, now you can say equals 2k, where k, the 2 coming from wait. I see. I see that now. Wait, so from here, if a squared equals 2 squared times 3b squared, then we can turn this b squared into just a dummy variable k that's an integer. And we know that it's going to be even because of this 2 squared. We could just say 2 times k, where k equals 2 times 3b squared. And then a squared equals 2k. Okay, and so now we have a squared is divisible by 2. And that means that, yes, that is exactly what that means. A squared is divisible by 2. 2 divides a squared. And can we show that 2 also divides b? It would also work if you have 3 divides a squared implies 3 divides a. Wait, I have to I have to understand that at an intuitive level. 3 divides a squared implies 3n equals a. Does it? I don't... Oh, I guess I get why. Because you could square both sides of this and then get a squared, and then you get 9n. And then you could just factor out a 3. And then, yeah, okay. I buy that. Oh, 9n squared. Yeah. And the same logic is happening here. So you're just saying... so this basically implies that a... this implies 2 divides a squared, which implies 2 divides a. Okay. You think there's a correlation between the speed of solving these problems and IQ? I wonder that all the time too, and it's like unfortunate. Like I just don't consider myself very experienced at solving these proofs because I don't know. I felt like I've kind of coasted through a lot of my classes so far and they haven't been that hard, but it's like to get into serious math, I just have to drag myself through like the embarrassing fact I'm not very fast and good at it, and eventually like it'll follow. But yes, that's definitely okay. You can solve faster by solving more. Oh, I see you're responding to. Yeah, I'm just gonna. I'll just keep practicing until I get. Can I summarize the last progress? So there's like a bunch of kind of useless intermediary steps, but basically, I guess I'll just rewrite up until this. So we've got. I'll do it in this area here just to be economical about paper. A over b squared equals 12, where GCD A B equals 1. So they're reduced. And then we have a squared over b squared equals 12, which leads to a squared equals 2 squared times 3b, which leads to a equals some 2 times another variable, which leads to, well, a squared, which leads to a, well, 2 dividing a. In other words, a equals like some 2n. So with a equaling some kind of 2n, we can substitute that in, I guess. And that means that like 2n over well, 2n, this whole thing, I guess, is squared, equals 12, over b. Now, do we know that b has a factor of 2? Like, if we were to rearrange, how are we getting b as a factor? Quite a short character limit. Oh yeah. Unrelated, but is there a way to remove the 3 traffic dots on Mac for either Chrome or Obsidian, Sire, Obsidian, Friend? Yes, it's just like CSS. You could honestly probably vibe code that. Rearrange for n. Okay. Why are we rearranging for n? So if we rearrange for n here, we've got 4n squared over b squared equals 12, which means that 4n squared equals 12b squared. And why does that help? N squared equals 3b. Yes, this is introductory analysis. Rearrange for n. I mean, like, divide by 4. N squared equals 3b squared. And then if you take the square root, n equals root 3b. Wait. Does that do anything? Because if you sub in root 3b, you have so n squared equals, so 3 divides n. So 3 divides n. No, you know what a is now. Rearrange the original equation to see what b depends on. Okay. B seems to depend on n over root 3. Here, now you can see the question. Is this cheating with internet real chatbot? Yeah, I guess so, yeah. In a sense. Wait, so 3 divides n. If n squared equals 3b, 3 divides n. 3 divides n. Is that... Why does that create a problem, though? I'm confused about that. It means some... ax, or that's a horrible way to... I'm not going to use that variable. Like 3x equals n. I'm confused as to why that's a problem. Product of rational and irrational number. Yeah, square root 3 times negative b. 3 divides n, you can take n equals 3p and show that 3 divides b. But I don't get it because... Oh. Yeah. So, that works if we originally said, because we have here that 3 divides a squared, or 4 divides a squared, or 2 divides a squared. And so if we have 3 divides a squared, and we have 3 divides b squared, that's why I was confused, because we had 3 and 2. Okay, so that makes a lot of sense now. And just to formalize it, I'm going to scooch this up a tad. All right, so proof. Assume towards contradiction. I love the contradiction symbol. That a over b squared equals 12, and GCD AB equals 1. And then we have that a squared equals 12b squared, which implies that a squared equals 3 times some integer k, which is 4b squared, which implies 3 divides a. And then we can go down here, and because we now have an n, you could probably say fix, but I'm not being that rigorous. We have 3n equals a. So now we have a 3n we can plug in here. 3n squared equals 12b squared. And I guess that gives us n squared equals 3b squared. Confused about that extra 4 though. We just have to get b into a form that it's being multiplied. It equals something times 3. It equals something times 3. And if we divide by 12, oh. What am I doing? So a equals 6k. Ren is making this overcomplicated. Shots fired, damn. You can show that 2 divides a by just seeing that a squared equals 2 times x. Yes, I agree with that, which implies similarly a squared equals 3y. Sure. Convince yourself that 6 divides a. Oh. Okay. Which is true because we have different ways we can factor this out. So this is the same as just 6 times 2b squared, which means 6 divides a. And since 6 divides a, we have like 6n equals a. And then if you plug a 6n in here, that's a lot easier because then you have 36n squared equals 12b squared. And then this is pretty simple. All you have to do is then cancel, and then we can see 3 divides b. And since, thank you for that. That confused me way more than it should. Since 3 divides a and 3 divides b, well, gosh darn, GCD AB not equal 1. Contra frickin' diction. Let's go! That was a lot worse than I thought it would be. Is the course I'm taking based on a specific book? Maybe not study with me, but let's grind some math homework together? Yeah, sure. Oh my god, I'm so relieved. I can practically kill myself. I'm so relieved. That was brutal. I'm never doing math again. I just finished my semester in past number theory and linear algebra, but failed real analysis. I'm sorry to hear that. Hopefully we can do some real analysis together and you can understand it a little more. Yeah, sorry about everyone's ears. Cool. Let's see. Let's do another problem. Let me bring this up. So problem 2. Problem 2, there's going to be some actual induction. I think I accidentally got like really thick pastel paper. It has like a rip line, but it does not want to rip. Wait, why would they have like a rip line and the binding system? Like, isn't this designed to be rippable? I don't know why I ripped that out. I mean, like, live and learn. Yeah, it's a Uniball Vision Elite. I'm not exactly sure why it's Vision. Maybe you're seeing what you're drawing. Yeah. Yeah, I'm sorry. I'm not all that good at math. Okay. Let's write this problem down. So, if A over B is less than C over D. Fractions. I've been scarred by fractions since the 3rd grade. With B is greater than 0 and D is greater than 0, prove that AC over BD, A plus C over B plus D lies between AB and CD. Okay. So, what this is basically saying, lies between, I'm going to clarify. I think what they're trying to say there is it's greater than AB and less than CD. I guess I'm not sure if it's greater than or equal to, or I'm not sure if it's like inclusive or exclusive? It's probably exclusive. Lies between, I would say. Okay. Prove that that lies between the two of them. What are we going to make use of to prove this? And we only get AB is less than CD. So, could someone tell me if that random guess was right? Like, is what they're asking you to show like the double inequality? So we have that, and we want to show that A plus C over B plus D is sandwiched between C over D and A over B. So let's start out with what we know is true. We know that A over B is less than C over D. And we want to get to that. So what's something I'm trying to think of how to approach this. It's not really an inductive problem. It's just like some algebraic rearrangement, I would guess. Are there any facts you think that I need to know? A divided by B let's see. I mean, we could add something to both sides of this. We could add a A over B. I'm surprised this many people are watching such a slow stream. Oh, this problem is quite nice. Oh. Yeah, that's an interesting observation. A over B minus this thing should be less than 0. That's interesting. Right. But we want to show that. We don't know that yet. But we could maybe apply something to get there. Hypertrophy has to be negative. What does AMGM mean? Hint, AMGM. Oh, I see. Yes, run in the background. Maybe that's what a lot of people are doing, because there's like low chat activity, but like a lot of people watching. What you can do is show is less than 0 and know it to be true. I mean, -1 is pretty much less than 0. I'm gonna be honest. But using this, I mean, we know A, B minus C, D is less than 0. And we can keep subtracting shit all we want, which is really cool. We can subtract as much as we want because this is an inequality. So we could potentially just stack as much as we want. And what we're trying to show is this over here. And as long as this term gets bigger because it's negative, we're chill. So it's completely fine to add anything we want on the numerator. The denominator, I think, is a little sketchier. I could be wrong. But because we know that it's less than 0, we could safely add that C on top, and then we'd be pretty well set up, I believe. So oh. I think I got something. Maybe. Yeah, if you're working, I was gonna distract you, but that's kind of mean. Probably already distracted hearing me say stuff. Any other things you could do to your starting fact to get an inequality less than 0 that could be more helpful? Maybe, but I was thinking of this, right? So because we have that C, no, that's for divides. I mean, we don't know that it evenly divides. It's dealing with real numbers. Never mind. You say prove this is obvious and say okay plus no problem. Chat say easy by contradiction, and I'm gone. I do not know what the supermom is, but I'm supreme confused. Any other things you could do to your starting fact to get an inequality less than 0 that could be more helpful? Oh, that's anything else you could do to your starting fact. I mean, we can freely add anything to the right-hand side. So we could very safely inflate. We could add whatever we want, and what we want to add to it is something that'll make it turn into an A plus C over B plus D. So basically, we want to figure out what we can add to this guy. I'll turn it into that. It's got a D in the denominator. So if we add a... God. How the fuck do you combine that shit? Any other things you could do to your starting fact to get an inequality that could be more helpful? Inequality less than 0. With C over D is greater than A over B. So we could multiply that. Oh. What if we were to add that whole term? Would that do anything? A plus C over B plus D. And that's allowed because it's on that side of the inequality. And then if you were to subtract that from both sides, which is allowed, you would get A over B minus A plus C over B plus D is less than C over D. A plus B, AB plus CD minus AB. I always forget about doing that little maneuver. Why is that less than 0? We know that AB is less than CD. Sorry, AD plus AD, AB plus AD. Rearrange the original, you'd have to add both sides. Rearrange the original inequality to AB, or AD is less than CB. Try to think of things to add to both sides of this inequality to get an interesting factorization. Okay, I'll try that. So A, B less than C, D, and then we could get A, D is less than CB. To get an interesting factorization, Um, so if we add if we add C an interesting factorization. Just use the LCM from the subtraction and things start falling into place. I see. So adding a CB. Well, I don't want to take too many hints from this, to be honest. And that's also why I'm not using ChatGPT, because math is like it's very important to build your intuition about how to solve this stuff. That's very interesting advice. To do it backwards, I mean. So like A, B, we want to show that that's less than A plus C over B plus D. And if you were to multiply both sides, if you got rid of that B plus D, okay. And it's interesting, like I guess a technique a lot that comes up in math is kind of like working backwards. And then A over B minus A plus C over B plus D. Um, okay. That, I mean, right, this is true, because then we can just cancel these, and we have AD is less than CB. Thanks, whoever said Jonathan Grube. That's a great trick to go backwards. Yeah, working backwards is fine here since you'll see all your steps are reversible, as that all your implications are actually if and only ifs, right? But there are cases where it would not be reversible, right? I mean, obviously, otherwise. Well, that's a wild comment. Oh my god. I appreciate that. Me trick was slick too. Alex plays. Hold on, I gotta go see. What was your trick? Do you even leave one? Oh. Oh. Oh, okay. I see your trick. Okay. So that is a great technique actually, to work backwards, and actually, could I ask in general, like, is working backwards in algebra, does that usually work just because like algebra is kind of reliable like that? Because then here we could do AD less than CB. That's literally the exact same thing. AD minus CB less than 0, and then or alternatively we could have just multiplied by each other. So to get the other way, all you would have to do is show, or to work backwards, CD A plus B, B plus D. This algebra intuition is not as obvious to me as it should be, but practice can remedy that. No need to worry. And then, yeah, this would be times D, and then this would be C times B plus D, and then we're going to get DA plus B is less than CB plus CD. Wait. DA plus DB CB plus CD. Is that correct? Did I do that right? No, I did not do that right. A plus B, C plus D. Oh, it's A plus C, B plus D. Oh my god, this is ridiculous. Okay, and then we get D times A plus C is less than C times B plus D. And then this is pretty easy. DA plus DC CB plus CD. Boom, boom. And then that implies that AB less than CD. I would say that working backwards can be reliable in these problems where it's a lot of symbol pushing, looking at this problem and just thought it would be tedious to come back with a trick. Just thought it would be tedious to come up with a trick. I looked at this problem and just thought it would be. When you looked at this problem, did you immediately say, did you immediately think to work backwards? Like, what was your thought process? After you work backward here, it's good to practice to write your formal proof. All right, let's write the formal proof. Alex plays. There's an infinite ladder of being mogged by people up the chain from you, unfortunately. So yeah, no matter, there is no stage you reach in anything where it's like, wow, I'm good at this now. Like, the better you get, the more you realize there's way more to do than you could possibly ever imagine. Like, I'm sure if I had a math PhD, I would be like, I would feel even more inadequate. I'm not entirely sure that's true, but as you get more into a field, like, your knowledge of it expands more and more and more, and then you see the whole scope. You see the whole landscape of all the unsolved problems, and you kind of gain an appreciation. It's like, if that makes sense. Oops. I already knew that the fraction was less than 0. I had thought about it before in some other context. No real intuition here. And you've just... Oh my god. Okay. I'm going to write this forward just for the sake of the formal exercise. So proof. All right. So we have all that, and we want to prove WTS that A plus C less than B plus D, or we want to show that that is less than A. Get rid of this nonsense scratch work. Want to show that that's less than... God damn it. I already messed up the order of this. That's why you don't use pen, I guess, but it's less than D over C and ... whatever. So first of all, we have, and we're given A over B less than C over D. This is a little bit sloppy of a proof, but that is going to imply that AD equals CB, which is going to be let's see. AD plus what do we want to add on each side here? I guess BA equals CB plus BA. Man, zoned out a little bit. Didn't sleep all that much last night. D plus B equals, and then b times c plus a. And then we'll cross multiply, and then a divide by b. Oh, this should not be an equal sign. Not sure how that happened. And then we get a plus c over d plus b. Okay, and that's one side. And then also this implies, well, we can use our same little guy there and say AD less than CB. But this time we want to add other stuff. We want to add what do we want to add here? We want to be able to factor out, we want all the big stuff to end up on this side. God, why is my brain so slow at this type of thing? Was B plus D, do we want C plus A? D plus C from the backwards work. Okay. And then we can rearrange this to be C over D plus B over, or A plus C. Okay, sweet. And now because of those two statements, we have surprising amount of people watching this. I guess everyone just does homework. Like this is unusually high streaming numbers. Yeah, I can get you into the Discord, and good to have you. Yeah, I'll be around probably tomorrow as well. No, coding videos are going to return, and no, I don't use the sweep anymore. I use my laptop keyboard. Now I do homework with pausing each stream and copying energy. Someone had an interesting comment that you could interpret the ratios as slopes of a line. As you represent them as vectors, then you could have slopes AB and CD. The sum, wow, that is a really interesting proof. And wow. Yeah, I would not have thought to do that. And the sum lies between the parallelogram formed, which gives you the bounds. Yeah, that's pretty brilliant, to be honest. Um, yeah, it's tough to sit with a problem. Very tough. Okay. See what else we can do. So problem 3. Hopefully this one will be more fun or quicker. If n squared is prime, prove that n is prime. So definition for the prime is it can only be divided by 1 and itself. And nothing else. So that means n squared, 1 divides n squared. In other words, m, actually, and then and nothing else. That's tough. That's a tough one. Contrapositive. Thank you. If n squared is prime. Oh, n squared minus 1. I'm sorry. That's a great clarification. Would have been there all day. Oh no. Okay. Use the contrapositive. Why? Okay. That's one I in fact know. How can n squared be prime? Yeah, it's not possible, because if it's you can show if it's even or it's odd, it ends up having 2 being. It's an honest mistake. Come on. Okay. Contrapositive I like, but like why did you think contrapositive immediately? Is it because you've done this problem a lot? Oh, it's not n squared, it's 2 to the n minus 1. Oh my god. Oh no. What would I do without this? I'm gonna see if I can bring my entire stream into the test. To the n minus 1 is prime. Prove that n is prime. That's really cool. That is really interesting. That is really, yeah. I think I kind of agree. I don't know why I feel like contrapositive also seems easier. Like, yeah. So if we say that the contrapositive, let's just negate and flip the implication, right? So like, n is not prime, aka composite, implies that not prime. So it's not prime implies that it has a divisor that's not 1 or itself. And to show this is not prime, we want to show that it has a divisor that's not equal to 1 and not equal to itself. You show something is not prime. What would divide that? What would divide that? Thanks. See ya. It's really Ren. Oh wait, did I misread the question? No. Okay. Mersenne numbers. Use a factorization of n to make a factorization. Oh, okay. Okay. So there's a factorization of n, and it's AB, right? AB equals n. So then if we have 2 to the AB minus 1, that's the same as 2 to the A plus 2 to the B. Is that correct? Jesus, my algebra 2 is falling apart. This is what like time off school will do to you. No. 2A times 2B, right? Minus 1. Show that this has a factorization. Well, I mean, isn't this a... Well, say 1 is 2 to the 0. Two A, 2B, products add exponents. Products add exponents. Oh, 2A to the B. Okay. 2A to the B. Yeah. Should have remembered that. And then minus 2 to the 0. Yeah, I got P2. You can go back and watch it. No big deal. Oh. Where's Alex Plays coming out of nowhere with this? Assume n is composite. You're right, n equals AB. Okay, did that. 2 to the n minus, or 2n minus 1 is also composite. Why is that a contradiction? Isn't 2 to the a to the b different from 2 to the a to the b? Not like this as well. It should be 2 to the a to the b. Oh, I get it. 2 to the a to the b. Wish I could spoiler tag in YouTube chat. Let me think about this for a minute before I like just cop out and look at the stream answer, because I want to build the intuition. Am I even going in the right direction with these exponents? I'm not even sure. I don't even know. Hmm. 2 to the AB minus 1. How can this be factored? What two things will multiply together to make that? Well, if we look at it as, like, could it be minus 1 and then 2 to the A, 2 to the A, to the B? Because if you multiply these two, the exponents add. B over 2? Is that allowed? That seems kind of goofy. I don't know about that one. Why do I not know about it, though? Like, what's funky about that? Can't really put my finger on it. Problem kind of relies on fact, non-obvious fact, factorization of a kind of polynomial. Okay. Yeah. Factorization of the difference of powers. Think about factorization of x to the n minus 1 or similar roots of n to the n minus 1. All odd powers of 2 minus 1. Oh, okay. So, think about the factorization. Someone left some good advice. Yeah, I agree. The factorization step, you kind of need to have seen the factorization difference of powers before. Try small cases. I guess that's an interesting, like, so, and we're working in the contrapositive. So, like, 2 to the 4 minus 1, which will give us 16 minus 1, 15, but, which is fine, but how is this going to be factored? 2 to the 4 minus 1. You could look at it as, was this in fact right? Like the difference of powers. You could factor it, it's gonna be like plus minus, and we're gonna have 1s here because that'll cancel out. But this first term is going to be 2, second term is going to be 2, and then it would be to the 2, right? Because multiplying them together, they're going to add. So wouldn't it be, like, for 2 to the n, wouldn't it be n over 2? Is that a valid solution? Those are 2 factors. Yeah, the n composite implies 2n minus 1 composite is the whole problem. Is what Alex plays correct? Says is correct. I can't. Factorization is just finding roots. The roots of x to the a minus 1 is a subset of x to the ab minus 1. Okay. Yeah, that works if n is even. But it doesn't work if n is odd. Okay, I think the b equals 3 case is enlightening here. We'll try b equals 3. You mean like x? You mean like 2 to the 3 minus 1? I'm still confused as to why you can't do like that. Remember, factorization is just finding roots. The roots of x to the a minus 1 is a subset of roots of x to the ab minus 1. Well, the assumption is 2 to the n minus 1 is prime, and we proved that if n is composite, then the whole equation is composite. The assumption 2 to the n is prime. This is if we're not doing the contrapositive. 2 to the n minus 1 is prime, and we proved that if n is composite, then the whole equation is composite. Therefore, n must be prime. Those aren't factors because they aren't whole numbers. Oh! The factorization of 3 or x cubed minus 1. It's been a long time. Are we talking about like... No, I haven't, honestly. You don't know that 2 to the a times b over 2 is an integer, real number in general. So you wouldn't have factored things into n times m, where n are integers. Okay. If x to the a equals 1, then still x to the ab equals 1. Setting x equals 2 gives you your required divisibility relation. Really? 2 to the a minus 1 divides. Oh. Oh, it does? If x to the a to the a to the b. I wanted to look up like what the factorization, because I do not remember this. Oh. What? Yeah, that is tough. I would not have remembered that. Right. Yeah. It's just that the other factor is horrible, and that is why Patrick Grill's method is nice and slick. Has n minus 1 terms, if not mistaken. So what you would factor it into is 2 to the a minus 1, allegedly. And what would the other factor be? We're looking at a 3-term polynomial. We're looking at well, this is a 3-term polynomial. The question is question 3. We're dealing with 2 to the b and then dash dash and a plus 1. I mean, I see that from the generalization here. So I see there's a plus 1. This middle term, I guess, is 2 to the a again. And then this is 2 to the b. Man, that is... the other factor is 1 plus 2 to the a plus 2 to the a squared. Oh, plus dot dot dot. There's a series in there, 2 to the a to the b minus 1. in general. Right, in general, because the amount of terms in this will just keep going up. But two to the a squared, 2 to the a to the b minus 1. But I wouldn't say computing 2 to the ab minus 1 times 2 to the a minus 1, or divided by, is the best. Yeah, man. Okay, I think I'm just starting to slightly grasp this. Like, we take that formula and then apply it, but sub in all these things where, and like this works generally with x. So our x in this case is 2 to the a to the b. But 2 to the a to the b Oh. Jeez, no. No, that is not it. Because x cubed minus 1 is that. But what we have is x to the n, basically. I see. Not a big fan. Most of the mathematical intuition is the idea of taking n equals ab and then knowing you need to factor x to the n minus 1 somehow. Finding the actual factorization kind of relies on previous knowledge. I guess you hadn't seen it before, and you would find it via small cases probably, which is also a useful skill to have, I guess. Yeah, because I really... Do you know how contrapositive proof works? That's how I would try to solve it. Assume that n is non-prime. That's what I was trying to... That's what I've been trying to do. It's just like finding the factors that's pretty tough for me to grasp. Wait, am I playing this song in the background? Is there music on this stream? If there is, it's not intentional. The x in this case is 2 to the a, not 2 to the a to the b. Why? I guess I want to see firsthand, and this might take a little, this might be an aside tangent, but just like x, I want to see the different cases of this. X squared minus 1 could be factored into x plus 1, x minus 1. X, because I know someone said this already, but I just need to figure it out. X cubed minus 1 could be factored into x minus 1 and then x squared plus x plus 1. X to the 4 minus 1. I'm assuming we're going to have an x minus 1 again, because the pattern starts x minus 1 actually. So x minus 1, but then in here we're going to have x cubed and then plus x squared plus x plus 1. Is that correct? Okay. All right. That's a good thing to know. I did not see that pattern before, so thank you for that. Small cases is good advice too. Dude, this is so awesome. Like, incrementally getting a tiny bit better at math. Okay, no. I think you're just trolling me. But that's awesome. Just to be sincere in your practice. Let's see. My advice would be try non-constructively to show that 2 to the a minus 1 divides 2 to the ab minus 1. Okay. All right. X minus 1 moment. All right, I'm going to try that. I'm taking your advice AF right now. Dude, YouTube channel for math help is OP. Who needs to go to a tutoring center when you have like a limited amount of plain text that's really confusingly formatted from 5 different people at once? All right. 2 to the a minus 1. 2 to the a minus 1 divides 2 to the ab minus 1. And that basically means 2 to the a minus 1 n equals 2 to the ab minus 1. And we know the expansion of this. It's for both of these we're going to have so x minus 1, and then that's times 1 plus x squared plus ... plus x to the a minus 1. And then on this side, we're going to have, well, don't forget the n. We're going to have x minus 1 times 1 plus x squared plus ... plus x cubed plus x to the a minus 1. The ... should be swapped with that, but you know, I'm not that rigorous. And so those are the two expansions. And do I believe that this divides that? I mean, this is the same and that's the same. So yes, I do believe. I do, in fact, believe completely. So the proof, if we have 2 to the ab minus 1, then we have 2 to the a, and then that's to the b minus 1. Then we can divide that by, and actually putting those in exponentials doesn't make it that much easier. So that means this is 2 to the a minus 1 times something. What is that times exactly? Well, is it times x minus 1? Or, and what I'm saying here is basically this is equal to that I say factor theorem, does that mean something? I did not ever learn that rule. So you have in general x to the b minus 1. X to the b minus 1. Substitute 2 to the a for x. Okay. That'll make it clearer. So then we have x to the b minus 1, and that's basically equivalent to x to the k minus 1 equals x minus 1 It's a generalization of the fact that x minus a divides f of x if and only if a equals, if f of a equals 0. Factor theorem, wow. Then in general you have x to the b minus 1. Yeah, go ahead, link an image. I don't know what moderation YouTube has for that. The factor theorem is really interesting. Alright, we lost the math setup. It was propped up on ski poles. Alright, should be fixed. You can see, like over here, let's see, I have this CRT TV on top of a sawhorse on my desk. Alright, we're back in business. You know how to factor x to the b minus 1. I was cooking for a second. I know how to factor x to the b minus 1 is x to the b minus 1 is just the series up to x to the b minus 1 is just it's x minus 1 times x to the b minus 1 minus 1. Am I crazy? Man, this algebra is oh my god. X to the b generalize it for okay. Not sure if this is too much of a hint. So you can generalize it. X to the 3 minus 1. So for x to the b minus 1, you can generalize it to x minus 1, and then you've got that series. It's a little confusing to me. I guess it's the x to the b minus 1 versus x to the b minus 1, if that makes sense. Like, I keep reading it, and then it's like blurring my my understanding. But you could, so you would factor this essentially into x minus 1 times 1 plus x squared plus ... plus x to the b minus 1. And those two factors are sufficient to say that you've basically you've shown it's composite, therefore you've proved. I think that's sufficient. Let's see. It's 3:45. I have time for maybe a problem or two more. Uh-oh. And yes, now you can substitute x equals 2 to the a. Right, wait. So 2 to the a minus 1, and now you could just say that would be 2 to the a to the b minus 1 equals 2 to the a minus 1 times 1 plus well, the 1 is, it's weird that I included it there. I should really say 2 to the a minus 1 plus 2 to the a minus 2 plus ... plus 1. And that's a factored version of it. Oh, are we losing the camera again? This setup is so janky. That might happen continuously. Okay, and I think those are valid factors. Do I get to draw a square? I have to actually write up these proofs at some point. I was going to one-shot this in LaTeX, but I don't know. I'll look like a sickly Victorian child. Thanks, I guess. Sweet. That is pretty. That's very cool. Thank you. I honestly, I'd never heard of that factorization theorem. That is very interesting. You say x is 2 to the a, I write 2 to the ab everywhere. Factorization escape. What is this guy saying? Yeah, I think I will do it in typed, but I don't know. I will do it in typed, actually. And let's see. We have two more problems. Show that sup and inf of a set are unique whenever they exist. Yikes. Okay. So this is basically least upper bound and greatest lower bound. Tip for when to consider contrapositives: if the implication you're proving is of the form not P, not Q. In this case, the case prime is defined as not composite. Yeah, that's true. Yeah. I mean, that's interesting because you could also define composite as not prime, though. But it's very easy to negate, I see. Okay, not quite. You don't need to remove exponents from 2 to the a. Substituting 2 to the a for x, and you should have something like 2 to the a minus 1 times 1 plus 2 to the a times 2 to the a squared times 2 to the a. Oh, I see. Yeah. I see. 2 to the a is the term. So it's, I see. 2 to the a squared plus 2 to the a cubed, and it's quantity cubed, dot 2a b minus n, b minus 1. Okay, thank you. All right, this next question. Show that sup and inf of a set are unique whenever they exist. So this one should be straightforward. I hope so. It's real analysis, and my textbook is, let's see, it's this. I'm not sure what people's opinions are on it. Mathematical Analysis, 2nd edition. My PDF reader broke, the good one, so I'm stuck using least upper bound. I just want to look real quick at the definition. Such that x is less than b for every x in S, then b is called the upper bound. And a least upper bound is, it's an upper bound, and no number less than b is an upper bound for S. So it's quite similar to like the GCD definition. I used to use Zathra. Well, I still use Zathra. It's just like this. It's really annoying, actually. Like, so I like maintain for a while the tap, like the homebrew tap. Basically, it's like a port from Linux package managers to Mac OS, and recently, like, the other maintainer updated everything, and then like it all broke, and I like auto upgraded by accident, and now like I have to downgrade, and like I don't feel like doing that right now. Real annoying. It is real analysis. Tony, you were a math major, right? Is there a different abstract algebra definition? Yeah. Do some... Yeah, real analysis is... It's a tough one. And I don't know. Like, I've also... I don't stream a ton, but like I'm gonna start streaming my homework, I think, because I need the help on it. Given non-empty subsets S and T of... Oh, no. So, the definition of the least upper bound is that it's an upper bound and there is no number that is less than it. So this is, someone say contradiction. This probably is a contradiction. Which means this looks different though. I'm curious, actually, Tony, do you find you use the math you learned in your degree for your current job? You find like the logical intuition primed your brain for programming better? So, assume towards contradiction. I guess we'll do soup first. That soup of S, blocked a little bit, that soup of the set S is not unique, which means that there are two different soups, which means am I correct in saying that? Like, well, I'd say 90% of it, no. It's just an IQ test for employers to see. 10% of it, yes, mostly from number theory and cryptography. Cool. That's good to know. I guess, yeah. It's true that it's just an IQ test, just a grind. Well, you would just say, assume there's two soup, then write definition, it violates the definition, and done. Is that legit? Are you allowed to just do that? And Big Wazowski, I don't think you need contradiction for 4. Just show soup is less than soup and soup is less than... Okay, that's interesting. Soup prime, sorry. So soup prime. Okay, I'll try doing that, I guess. No more contradiction. So soup prime less than soup less than equal to, and soup prime greater than equal to soup, which, if is true, will imply that they are equal to each other. And the definition of the least upper bound is it's an upper bound, and no number less than b is an upper bound for S. And then this is the same thing as saying b prime is greater than b. No. No number is less than b. B prime is greater than or equal to b. And you could do contradiction. I'm surprised, like, you held on to the ability to do proofs. I feel like it would go out the window for me a few years after. I'm surprised all of you if you're out of school, but I don't know, maybe I'm just... I feel like it would kind of rot if you didn't use it as an ability. Oh yeah, esoteric finance people. Like the people at Jane Street or something. Okay. I'll try direct. Maybe I'll do both just for the heck of it. Okay, and so that's the definition. It's B is an upper bound, and then all B prime is greater. And say an upper bound because every number greater than B. And an upper bound is just every element in the set is less than or equal to it. And the least upper bound is just like the least upper bound, every thing else is greater than the least upper bound. So you could have an upper bound, you could have a bunch of upper bounds, but the least upper bound you've got one of. And that's, in fact, what we're proving today. Oh, we've got artificial superintelligence in the chat. Okay, put effort into good writing. Okay, yeah, that's good feedback. I kept seeing proofs. Once you understand, you sort of never forget. Yeah, I guess so. All right. So we can show that soup prime is less than or equal to soup. So let's say soup prime. This means that every B is greater than or equal to it. So whatever this is, whatever the soup is, it'll be greater. This seems like, okay, someone help me out here. This seems like so dead obvious, just like apply the definition, but something feels like off about that. Is there more rigor involved before you just spam that, like, I don't know. We're just using property B of the definition. Hello, Chilean guy. Or girl. Probably guy. No, it follows from the definitions. So literally all you're doing is just saying that you have a least upper bound, and then you have another least upper bound, but everything is greater than that least upper bound. So that's true. And then you have a least upper bound and a least upper bound, and everything is greater. So that's it? I mean, this one is literally just using the definition. Mind that soup must not always be in the set. Yeah, I think ceiling is different. Yeah, I'm trying to prove that it's unique, but okay, for the sake of mathematical rigor, someone said write this out completely because I've been being very sloppy. If you have 2 points and one is smaller than the other, can they both be the smallest? No. Yeah, you'll see a lot of problems you can get just by writing the definitions. Okay. All right. So I'm going to write this out fully. Proof. And we are, I guess above it, I should write soup and what's the other one? Inf of a set are unique whenever they exist. I have a question here. Could you legally, are you allowed to say without loss of generality when you're doing this soup prime is less than soup? Is that a legal case for that? Oh. Does that constitute a proof? Like the well ordering principle? You just say the set of all upper bounds and then, okay, inf equals negative soup, negative x. Yes, it's analysis. I just meant without loss of generality, if you're showing like soup prime is less than soup, less than equal to soup, and soup is less than or equal to soup prime. Although I guess, yeah, I don't know. This is true even on sets that aren't well ordered. Could I say for my proof, consider S as the set of all upper bounds? by the well ordering principle. We have exactly one least upper bound. Is that all right? The reals aren't well ordered. Ah, you're right. You can use, and you are not using well ordering. Money spread right now. Are the reals ordered or aren't they? Problem is effectively assuming the set is well ordered by saying assume supermum infomum exists. Oh, fighting words. Not sure who to trust. Kind of a language game. By saying the least, you already know that it makes, yeah, I mean, but I just want to make sure I'm rigorous enough. So are no well ordering of the reals. Okay, so that is not a valid proof. All right, we'll start over then. And just say that want to show sup prime equals sup first show sup less than equal sup prime less than equal to sup, which implies that this is the least upper bound. So everything is greater than or equal to it. What would I say? Like, what would I write to invoke the definition there? Okay. Easiest proof is use proof by contradiction. Suppose you have two distinct sup of a set. Then show they are both less than each other using the sup definition. x in S, it's the case that x is less than soup. Now substitute x equals soup. It is the case that for all x, it's less than for all x in S, it's the case that x is less than or equal to, no, just less than soup S, and then we have soup prime less than soup I'm missing the less or equals here. Maybe just in the definition that's not correct, but geez, real analysis is picky. No number less than V. Less than. And so less than or equal to. Oh, okay. Okay. All right. Now, show soup less than soup prime for all y in S. It is the case that y is less than soup prime. And now substitute soup prime, since soup prime less than equal to soup, and soup less than equal to soup prime, soup equals soup prime, little square. Is that valid? Where they're not an S. Yes, you are correct. Yeah. I see. Oh. Alright, I have to go because I have ski practice. But I'm going to resume doing homework probably tomorrow. It would also be ideal. I'll drop my... well, just email me or contact me if you're like... if you think you can hop on a Discord call. And yes, I realize this proof is incorrect and incomplete. I'm finishing it another time. Alright.